Hello guys, welcome to a new chapter. What you're going to be working on today is called Criss Cross Method. And you're going to be using the charges that I already gave you on your periodic table, along with the polyatomic ions that you got yesterday. Okay? These notes you're going to put on page 24 of your INB notebook. Okay, let's get started. Yesterday and a couple of days ago, I gave you the charges for every single element that you have. So let's take something that we did a couple of days ago. Magnesium is on your periodic table. It's in that second group, that Earth family, and that group, all of them have a +2 charge. When you have something like, let's do phosphorus. Phosphorus, if you look at your periodic table, is going to have a -3 charge. Now, what do I mean by crisscross method? This number is going to cross down here, and this number is going to cross down here. So your answer is going to be Mg. Now, the elements stay the same. Your cation always is on the left side, and you're going to have that 3. The phosphorus is going to have the 2 from this side, from magnesium. Now these numbers are no longer a charge. So there's no positive, there's no negative, it's just the number. And what this means is that you have 3 magnesiums for every 2 phosphorus. And this gives you the correct oxidation number. Okay, now that's the short version. That is the shortcut. That's how you're going to do your assignment today. Now, why do we do that? Why do I have 2 phosphorus for every magnesium? Okay, the long version is magnesium, which has a +2, phosphorus, which has a -3. If I add these two together, a +2 plus a -3, I'm going to have a -1. And my objective here is to get 0. It has to cancel out. So what if I add another magnesium? Well, that's another +2. So this would give me a +4 plus a -3. This now gives me a 1, a +1. Now, does that equal 0? No. So we can't use that. We're going to erase that. And now we're going to go back and put another phosphorus. So here, a +4 plus a -6 is going to give me a -2. Still not working out. It's not giving me that 0. It's not equaling 0. So let's add another magnesium. This is also a +2. Remember, every single magnesium has a +2. So 2 plus 2 is 4. 4 plus 2 gives me that +6. Now phosphorus has that -3 plus -3 gives me that -6. So now a +6 plus a -6, now I get my 0. We see that? So now that the chemical formula is balanced, it took 1, 2, 3 magnesiums, and it took 1, 2 phosphorus to give us that 0 oxidation. Okay? Is this not the same answer as this? Okay, so we see how that crisscross method is just a little shortcut instead of doing all of this. But now you know the reasoning behind it. Okay, so now let's do something else. As long as you have different numbers, 0 that you did here in the first page, okay, so by reducing it, you actually get that 0. Things are going to crisscross. If I have calcium with a +2 and nitrogen with a -3, it's going to crisscross. Remember, it's going to come to the bottom. So calcium does not move. the 3 comes down without a charge. Nitrogen also does not move. The 2 just comes down here without a charge. Okay, this is your chemical formula. I have 3 calciums for every 2 nitrogen. Now that's because these numbers cannot reduce or cancel out. And what do I mean by cancel out? Well, if I have something like, let's stay with the calcium, a +2, but then I have an oxygen, which is a -2. Are these two the same number? Yes. So because they're the same number, they cancel out. 2 divided by 2 is 1. So what's going to be left is just the Ca, you have one of them, and oxygen, you have one of them. This will be your chemical formula. Now it doesn't matter, it doesn't have to be a 2. It could be something like aluminum with a +3, and then nitrogen with a -3. Again, because it's the same number. If I give you 3 apples and then take 3 away, that equals 0. So all you have is just 1 aluminum and 1 nitrogen. That's it. Okay? So that's if they're the same number. Now, what if they have the same, or what if I can reduce something? Like, let's take lead. And lead, you can have a +4, you can have a +2. It just depends on which one you have. Now, how do I know what charge this is going to be if it's a group B element? The Roman numeral is going to tell you what the charge is. So here you would have something like lead, Roman numeral 4, and I ran out of space there. This Roman numeral tells you it's a +4, okay? And then let's do something, like sulfur. Sulfur in that group is a -2. So now, can I divide 4 divided by 2? Yes. They have a common denominator. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So what's going to crisscross? The reduced number. So it's going to be PB, you don't have to write a 1, S, and the 2 goes down here, the reduced number. So now, if you have the ability to reduce, you must reduce. If not, it's not going to be right. Okay? So if you had something like this, like PB2S4, this would be incorrect. You must reduce. Okay? Because your main objective is to do right. I want you to do the worksheet that has the charges already there for you. Okay? And then let me know if you have some trouble with it. Okay, here are some more practice ones. Let's do number 5, just to make sure we're in the right place. Aluminum has a +3 charge. Fluorine, if you look at the halogen group, has a -1 charge. Are they the same number? No. Can I reduce them? No, so that means you're going to crisscross them. So it will be aluminum, you don't have to write the 1, and then fluorine 3. They crisscross. Okay, so for these, you're going to practice with these, and you're going to put these in your notebook, and you're going to show it to me for your stamp. Okay? Now let me give you another answer. Something like silver, that's in the group B area, it's going to give you a Roman numeral. So like silver, Roman numeral 1, and then iodide. These are your binary compounds. Okay, so silver, because of this Roman numeral, it's a Roman numeral 1, so it's a +1. If it had a Roman numeral 3, then it would have been a +3. Okay, now iodide is in your halogen group. That comes from iodine. So it's going to have the same charge as your halogens, and that's your -1. So now, do we have the same number? Yes. So they cancel out. your answer is going to be AGI. And that's it. That's your answer for number 8 as well. Okay, I want you to do the rest and put those in your notes on page 24 of your INB notebook. Now, what about if they give you the names and you have to write the formula? Well, it's kind of the same as here, but instead of giving you the symbol, they're just giving you the name. So what's my symbol for iron? If you look at your periodic table, iron is Fe. Now, how do I know when it's a transitional metal what my charge is? Because remember, you can have more than one charge. Here, it's giving me a Roman numeral 3, so that's why my charge will be a +3. Sulfide is an element. Remember, anything that ends in IDE is an element. And so that comes from your periodic table. And sulfide comes from sulfur. And that group has a -2 charge. That's from your oxygen family. So now, are they the same number? No, so they can't cancel out. Can I reduce it? No. So this means you must crisscross your charges. So you're going to have Fe2S3. Okay. Now what happens when I have a compound? You're going to do the rest of these. By the way, zinc is a Roman numeral 2. If you're really listening, let me go ahead and give you that answer. That's going to be a bonus right here. Zinc is always a +2. Fluoride is a -1. Therefore, you're going to crisscross the charges. So your answer is going to be ZnF2. Now, these are binary compounds. You only have 2 elements. All of these come from your periodic table. That's where you're going to find the charge. Okay? Now, what happens if you have more than just 2 elements? Let's do something with a polyatomic ion, like the list that you had yesterday. So yesterday you had, let's say, calcium has a +2 because it's in that earth group, in the earth alkali earth metals family. Okay, and let's do sulfate. Now look at your polyatomic ion chart. What was sulfate? It's SO4 with a -2. Now, are these 2 charges the same number? Yes, so they cancel out. And all you have left is just the element CaSO4. Now, this number on the bottom never moves. Let me say that again. This number on the bottom never ever moves. If you move that number, it's already wrong. So if you move, instead of putting the SaSO4 and you put something like SaSO2 because of the charge or whatever, that would be wrong. Okay? The numbers on the bottom never move, because what this means is you have 4 oxygen. Here you have a sulfur, you have an oxygen, an oxygen, an oxygen, and an oxygen. If you move this number, that means you change your compound. So if you moved it to, like, let's say an SO2 or an SO3, then that means you would not have the 4 oxygens, you'd have 2 oxygens, and that would be incorrect. Okay? Let me know if you're stuck there. Okay, now anytime you have a compound, whether it has a number on the bottom or not, when you crisscross a charge, that means you have to isolate that compound. So let's say instead of sulfate, let's still use the Ca with a +2, but let's use phosphate. Okay, if you look at your chart, phosphate is PO4 with a -3. Whoops, wrong number right there. -3. I was looking at calcium. So now here you have a 2, here you have a 3. Are they the same number? No, so they cannot cancel out. Can I reduce them? No. So then what that means is I must crisscross them. Now calcium's an element, so I can just do what I did in the past. Ca, and the 3 goes on the bottom. PO4 though, is that an element? No. If I have 2 capital letters, that means I have a compound. Even if I have something like CO and I don't have any numbers, that's a compound. So if I have a compound, you remember that 4 never moves. It must stay there. You're going to put it in parentheses, and this number is going to go outside of the parentheses. So that 2 is going to be on the outside. Still on the bottom of that chemical, but now this is going to be isolated in parentheses because it's a compound. Okay, so let's do another one. Let's do, let's see. Let's do something like aluminum. Aluminum hydroxide. Okay, and I know you can't read my handwriting. I'm trying to squeeze it in. Aluminum hydroxide. Aluminum is Al, and your charge for that is a +3. Now, if you look on your polyatomic ion sheet, your little cheat sheet, hydroxide is OH, and it has a negative. So, looking at your charges, are they the same number? No, so you can't cancel. Can I reduce them? No, they're already at its most reduced. So you must crisscross. Now, just like this compound, this is also a compound because you have 2 capital letters. Okay, if it was oxygen by itself, then you'd be able to do the same thing that you did in the other frame, where you have just the elements. So something like, let's say aluminum and oxygen. I believe this is one of the answers to your worksheet. Aluminum is a +3, sorry. You're going to crisscross. So it would be Al2O3. And you don't have to have parentheses because oxygen's by itself. But here, oxygen's not by itself. It has hydrogen as well. So this is a compound. It's not an element like this one. Okay, we see the difference? So Al will be 1. You don't have to write a 1 down here. You never have to write a 1 when it's just 1 next to the element. Hydroxide, though, is a compound, so that 3, we cannot have this here. That would be incorrect. We must have the parentheses. Okay, and let me show you why. Let's go to the next frame. When you have a compound like this, it must be in parentheses. Okay, whenever you have a polyatomic ion. Okay, let me know if you have any questions. Aluminum like this and aluminum hydroxide like this are completely 2 different elements. Why? Here I have aluminum attached to an oxygen that has a hydrogen, another hydrogen, and a hydrogen. Okay, that's one compound. Now here I have aluminum with an OH group, an OH group, and another OH group. We see the difference there? Here you have 3 O's, you have 1 aluminum, you have 3 oxygen, and you have 3 hydrogen. Here you have 1 aluminum, 1 oxygen, and 3 hydrogen. You see how you're missing 2 oxygen over here? That's why this would be wrong. And this would be correct. These parentheses tell you that you have 3 of this particular compound. Okay, so you must